This is PMS Math channel. On the set of natural numbers, let R be the relation defined by A or B if 2A plus 3B is equal to 30. Write down the relation by listing all the pairs. Check whether it is first one reflexive, second symmetric, third transitive, fourth one equivalence. Solution. Here the relation R is nothing but A or B. It is given. Here A or B means set A comma B. Here A and B belong to N. N is nothing but set of all natural numbers. That set is given set of all natural numbers. Means N. And an equation is given 2A plus 3B is equal to 30. Here first we have to write the elements of the set R. Relation set R. Here we have to write the elements. That means A comma B. Find out the values of A and B. We can take first ordered pair 3 comma 8. That means A is equal to 3, B is equal to 8. Here we can substitute A is equal to 3 and B is equal to 8. 2 into 3, 6. 3 into 8, 24. 6 plus 24, 30. That means this equation is satisfied with this values of A and B. Then take next one. Next A comma B. A is equal to 6 and B is equal to 6. 2 into 6, 12. 3 into 6, 18. 12 plus 18 is equal to 30. That means this equation is satisfied again with this value of A and value of B. Then take next one. 9 comma 4. That means A is equal to 9, B is equal to 4. 2 into 9, 18. 3 into 4, 12. 18 plus 12 is equal to 30. That means this equation is satisfied with this element also. Then take next one. A is equal to 12 and B is equal to 2. A is equal to 12. 2 into 12, 24. 3 into 2, 6. 24 plus 6, 30. This equation is satisfied with this element A comma B. Or A is equal to 12, B is equal to 2. Here this equation is satisfied with only these elements or these values of A and B. Now we got the relation set R 3, 8, 6, 6, 9, 4, 12, 2. Then first one. The relation R is not reflexive. Reason is here 1, 1 does not belong to R. 2, 2 does not belong to R. 3, 3 does not belong to R. Etc. Last, generally A, A does not belong to R. For all, A belongs to N. Here N is set of all natural numbers. First natural number is 1. 1, 2, 3. 1, 1, 2, 2, 3, 3, 4, 4. Generally we can say A, A does not belong to R. For all, A belongs to N. This is nothing but A, A does not belong to R. For all, A belongs to S. S is general set. 4. Here, condition for reflexive relation is A, A belongs to R. For all, A belongs to S. But here, does not belong to R. Here, does not belong to R. In this case, we can say given relation or this relation is not reflexive. Then, second one. The relation R is not symmetric. Here, first element 3, 8 belongs to R. Okay, but 8, 3 does not belong to R. Then second element 6, 6 belongs to R. 6, 6 belongs to R. Here, okay, but 9, 4 belongs to R. Gives 4, 9 does not belong to R. 12, 2 belongs to R. But 2, 12 does not belong to R. That means A, B belongs to R gives B, A does not belong to R. 4. What's the condition for symmetric relation? A, B belongs to R gives B, A belongs to R. But here does not belong to R. Therefore, given relation is not symmetric. Now, third one. The relation R is transitive. Since, take first element 3, 8 belongs to R. Then take 8, this is null element. This null element belongs to R, we can say. Now, here 8 and 8 are equal. then we can take this number, first number and this last number. 3 comma this number. This number is not known. Therefore 3 comma. That means 3 comma means null element. This null element also belongs to R. Null element belongs to R. This null element belongs to R. Again, second element. Take second one. 6 comma 6 belongs to R. Then write again 6 comma 6 belongs to R. Gives 6 comma 6 belongs to R. That means A comma B belongs to R. B comma C belongs to R. Gives A comma C belongs to R. Then take third one. 9 comma 4 belongs to R. But 4 comma this element is null element. This null element belongs to R. Then take 9 comma. That means here 4 and 4 are equal. Then take first number and last number. 9 comma this number. This number is not known. That means this element is also null element. That null element belongs to R. We can say null element belongs to R. Then fourth element, 12 comma 2 belongs to R. But 2 comma here, this is also null element. Null element belongs to R. Then now here 2 equal. We can take 12 and last number. First number and last number. 12 and last one. Last one means this one. This number is not known. Therefore, we can say 12 comma. This is null element. This null element belongs to R. This condition is satisfied here. Therefore, we can say given relation R is transitive. Then fourth one. Here the relation R is transitive, but it is not reflexive and not symmetric. Hence, R is not equivalence relation. What's the condition for equivalence relation? If a relation is reflexive, symmetric and transitive, then we can say R is equivalence relation. But here R is transitive, but it is not reflexive, not symmetric. Therefore, we can say R is not equivalence relation.